So, welcome everyone to my brown bag on the Axon Framework. So we'll have a bit of a whistle-stop tour through what Axon is and some examples of how you use it. I played around with it a bit, built a sample app, and found it to be pretty useful. I think it's quite a reasonable framework, so let's get started. So, what is Axon? It's a CQRS framework that supports event sourcing and there to build scalable, high-performance applications. Great, straight out of the box. But what is CQRS? It's Command Query Responsibility Segregation. 4 words which might mean nothing to you, but it's first time you've heard it. So where does that itself come from? What's that? It comes out of some stuff that Bertrand Meyer originally did, which was command query separation, so CQS, which is not quite the same as CQRS, but so this is when in his book Object-Oriented Software Construction. And so what was the point of that? He was saying that when you're designing your objects, your classes, you should separate the methods into command methods and query methods. And so each individual method should either be a command or it should be a query. It shouldn't be both. So what does that mean? Well, here's an example of a interface to a class, the customer service. It's got an add method which takes a customer and probably adds it to some service or some database, and it looks like it returns a customer. Maybe that's the customer objects that have been added. Update, similar sort of thing. Maybe that's the result of the update. Maybe it's got a new version number in it or something like that. Get seems pretty clear that it's actually getting a customer based on the ID you pass in. And then you've got this final method, which badly named, obviously, ambiguous. You're not quite sure what it's doing. It takes something in to do something, and it returns a customer. Now, is that doing a query? Is it going to change the state? You can't tell from just the naming and the design of the class. So, by applying CQS, you can make it clear what each individual method does. So, whether it's going to mutate the object, like the first two, they don't return anything, so they must be a mutation method. Or the final two, get, or now unambiguously a query, which must return, an object and therefore must be a query and should have no side effect. So that was the original idea of CQS. CQRS itself then goes further and it segregates those command methods and the query methods, that responsibility for updating and querying, into 2 different objects rather than 2 different types of methods within the same object. So now we would have a command customer service which only does the mutation methods, and a query customer service which only does the querying and has no side effects. So far, pretty simple, not particularly exciting, but by doing CQRS it actually allows us to do some interesting things architecturally. So, for example, it allows you to have different properties for your query and your command services. You can scale your query services across many servers and your command across just a handful, because typically the processing requirements are inherently asymmetric. You'll have a lot of queries, very few updates, probably. There are obviously cases where you can switch that around. You have a lot of updates with very few queries, but it allows you to have that flexibility. Another thing it allows you to do is to break from the concept of, well, since this uses the same data, we should use the same data model. So if you think about a CRUD-based system, you'll typically use the same entity object, same model object coming in, coming out, used for query and used for commands. So we saw earlier that customer service used the customer object. So that sort of model lends itself to CRUD-based UIs with update in place, etc. So, you know, you then start thinking, well, how do we handle history? How do we handle audit? How would we handle things which don't quite fit that paradigm? If you have a different model, or you're allowed to have a different model, for your commands versus your queries, and for different commands, you can have perhaps a more task-based UI. You know, it supports that, where everything's based on the intention of what the user's wanting to do. So you can imagine, here's an example, if you're going to change a customer's address, in a CRUD-based system you'd probably have a customer object with maybe its address entity associated with it, and you'd say update. You can't tell whether that update is because the customer's moved house or because you're fixing a typo in their address. Whereas if you have a different task-based UI, you could say, right, I'm actually going through the business process of them moving house, and will issue a move house command, or I'm going through the process of they've told me I've spelled their house name wrong, so I'll go through a fix the address typo command, and then you know what's gone on and why it's gone on. So that's CQRS. Because you've got that flexibility, it allows you to think about things in a slightly different way, which may be more appropriate for the sorts of ways that people want to interact with systems. So alongside that, we have event sourcing. It's not directly related to CQRS, but as we'll see, they fit very well together. So event sourcing is the concept where instead of storing, you know, the entity and maybe its current state, perhaps its history, you store the set of events that happened to the entity to make up, over its life cycle to get to its eventual state. So let's look at some examples. So perhaps a traditional relational model where we're modelling users. First one models 2 users, just shows the current state of those entities, and we don't have any history. We've lost that information. We don't know how it got into that state. Second part shows keeping a history of that. So the user John has only ever been created. The user Simon, however, has gone through a number of steps. And we can probably determine what happened at each step by looking at the differences, but it can get a bit complicated. And you also have to think about, well, how do we then query this model? Maybe we need some complexity around how we store it. Maybe you have a header record which points to the current version, etc. It can get a bit complicated if you want to look at that data.
How do you know my password, John?
Yeah, you changed it on the 23rd of January, yeah. But if you look at the event sourcing instead, we're just storing the events that have happened to those objects. So the user John has only ever had a user-created event, which has just all the information required at the creation time. User Simon, however, has had 4 events applied. So there was a creation event, followed by a user disabled event, which doesn't actually have any data associated with it because the intention doesn't require any other information. It just needs to know which entity, ID 2, but it happened the second event on this date, and it was the user disabled event. Similarly, user enabled, and then finally a password change. So we can see what has happened over the life of that object. And with event sourcing, you can then play those events in order, and you'll get the current state of the event. So they're different concepts, but they work really well together. So CQRS works in terms of commands, event sourcing in terms of events. So what is the difference between a command and an event? So a command is an intention. It's saying, I would like to do this, and it could be rejected. You might say, sorry, you can't change this password. Maybe the password isn't long enough, or actually you're not logged in, as that user, so you can't change their password. So we typically use present tense or future tense, but present tense is more typical. So the command might be called change password. Whereas an event is actually a fact about something that's happened. It's saying this has happened, therefore there's no concept of rejection. You can't say that I'm not going to allow that event to happen because it's saying it has actually happened, and therefore you typically use past tense for that. Password changed. But that means actually the concept of events makes life quite. You've got something that you can conceive in your mind. It's all the things that have happened. If you're playing the events, you know that they must have happened, so there's no processing that you have to worry about. You just say, oh well, that is a fact about what's happened in the past. So now let's introduce Axon. Axon is a CQRS framework, and it supports event sourcing, although event sourcing isn't required in the framework. Here's a sort of high-level diagram of how you build might design a CQRS application, and a Axon application typically follows this approach. The command and query is separated between the top half and the bottom. So the top half is talking all about commands. So your user interface will issue those commands, which will get taken by some sort of command handler, whose job it is to talk to your domain, access the repository, and get the domain object and apply those commands to that object, which then issues events which get handled by the query side of it. So let's just have a look at that in a bit more detail. So in a CQRS application that's event sourced, the way that would happen is you'd have a command come into the command handler. The command handler will say, oh well, this command is for entity 1 from my domain, for example. So what I'll do is I want to have access to the current state of entity 1. So I'll ask the repository to give me the current version of entity 1. The repository in an event-sourced application will say, right, I'll create a blank object, I'll load all the events and play them onto that object, and now I've got the current state. And I can then apply my command to it now, and then it will decide, am I allowed to do that, am I not allowed to do that, what are the business logic and invariants that I need to apply. Assuming it is allowed to happen, that might result in a state change, and if you get a state change, you'll issue a new event, which will then get stored in the repository and in the events store, and then published to anyone who's interested, so the event listers. And then, when that command is complete, it throws away that instance. So that's sort of the canonical way of how a command is processed. As we'll see later, that there's some efficiencies that you can implement to mean that you don't have to replay 10,000 events if your object is particularly long-lived, which you'd often find. On the query side, we receive the events which say these things have happened to this entity, and we just store any data we require to be able to satisfy the types of queries that we are interested in. So we might have here, we've got an analysis database, which is there maybe for some data warehousing, business intelligence queries. You've got another database which is there for online queries from the client, and you've got a component which is there sending messages. So you can imagine you might have something that says, oh, you've changed your password, did you mean to do that, was that you, etc. That sort of thing. That would just send an email. Because we use events, and we use an event bus, we're decoupled from the domain object. So we don't need to worry about, when we're writing the code for let's do a change password, you don't need to worry about whether you're later on going to send an email, whether you're just going to update your, say, Spring Security database to allow authentication, etc. Whether you need to have business reports of it, you're nicely decoupled. The other great thing about this is this database that you use for your online queries can be shaped specifically for that query. So your domain might be a really complex domain. You can imagine, you might have a customer object which has got addresses, it might have employees, relatively complex set of tables would be required to store that. But if you're just querying saying, well, give me the employees with the customer name, you don't necessarily need to do lots of joins if you just store that in a table that is representative of the data that you need to query. And you can set up the indexes required for that query on the instance of the tables you're using for that, to satisfy that query. And if you don't need that query again in the future, if your business logic changes, you can just throw it away. If you create a new query, you've got a new requirement later on, you can say, right, okay, we'll create a new query database, and what we'll do is we'll ask the system to play the events to that component, so you can then set up your data from scratch. Ultimately, the event store is the master information of the state of your system, and all of these other systems can be thrown away and rebuilt by replaying the events. So that's sort of the basis of what an Axon-based application is. And so for the rest of the talk, I'm going to walk through sort of how we actually would implement the individual component parts of this system. So let's start about commands. In Axon, commands are just simple POJO objects. So you just define something like, oh, I'm going to change my password. So my command is called change password, and it just has on the fields that you need to express the intention of what you want to do. So probably an identifier and maybe your new password. So because it's a POJO, it makes it ideal for immutables. A command, once you're saying this is my intention, isn't going to change. It is immutable. So you can just send that in and work with it. The idea is it's the expression of intent. So you've got your UI component. How does that then actually get that command to the right place? So Axon provides a framework for dispatching commands and routing them to the right place. And sort of the lowest level of that is what they call a command bus. So the idea is you have a command, put it on the command bus. Axon decides based on the event, the command type, where to send it to, and there's always, at most, a single command handler. So there's only one place which will handle each individual type of command. In fact, there might have to be exactly one type, or one place. They provide a couple of different implementations, depending on how you want to do it. There's a simple one, which basically does it all in the same thread. So your caller dispatches the command, it gets sent to the command handler, it does all of its work, and then that method returns. So you wait until your command has been processed before your dispatcher thread returns. So pretty much the same as you would do in a traditional application. You wait for your service to process the operation before you move on. That means it can all happen in the same transaction if you want it to. But perhaps more interesting is to do these things asynchronously. So if you can design your commands so that they are fire and forget, you can return back to the client very quickly, get high throughput, pass off processing onto different threads, different objects, etc. So one of the things that they provide is a command bus based on the disruptor pattern. So they've taken the stuff that, for example, Nick and Martin, etc. know about from LMAX. So they've taken that as a pattern. So you can just build your application, plug that in using Spring, wire it up, and you've got that behaviour out of the box. There are some limitations that you have to be aware of, but that's documented. So how would we actually do this? Well, we first of all have to create our command. So in this case I'm creating a start command using immutables, which is that builder pack you can see there. But obviously it's just a POJO, you can just construct it however you want. And then you call the dispatch method on the command bus object. It has a void return type, so you can't wait for things, so it doesn't force you to sit there and wait for something. But you do have to wrap it in this command message object, and they've got a concrete class, generic command message. So it's a very basic API, but what happens if we do need a result, if we're going to wait for the response, like maybe it's a validation check that you want to see. To do that, they provide a future mechanism with a future callback. Status here is my own type of class, so I'm checking, sending a status command saying what's the status, and I want the status object back. So status is not an Axon thing, it's my own class. And you just pass the callback into the dispatcher when you dispatch it, and then you can ask for the result, which will then wait for, it does all the thread synchronization handling to wait for the response back, and will then return the result to you, or throw if it threw an exception, it will give you back, it throws a wrapped exception of a runtime exception for you to use. So that's pretty low level. They actually provide then a sort of higher level of abstraction called command gateway, which wraps that command bus but provides some other capabilities. So you can implement a retry policy. So if the command fails, you can say, well, retry it 3 times. If it's this type of exception, stop, whatever. And you can put interceptors on there. So an example might be a validation interceptor. Someone does bean validation. They want one of those out of the box. Or an audit, which is just going to log each command that gets processed, etc. So how do you do that? Well, you create a command object just as you would before, but they have a command gateway interface, which is a bit more user-friendly. It has a send method, which takes your command so you don't have to wrap it yourself. And if you need a response, they have a send and wait method, which returns the type, or will throw the wrapped runtime exception as appropriate. And that's a generic method, so it says R send and wait of type R, so you can then say, I want it to be status, for example. But again, so it's still working really in terms of objects for your input, and you don't know the types that you get back on that interface. So they allow you to build a custom command gateway, which defines a strongly typed interface to your system. So it wraps around command gateway, implements all the retry policy and interceptors that does, but also allows you to define how exception handling will work, because you just define an interface, strongly typed interface, for your command handling. So in this case, we would define an interface called use gateway, which has a start command, so it has a void return type, so it's not waiting for anything, and it takes the strongly typed command start command, so you know what's going on there, and then you just call the method as you'd expect, start with the command object. But if you want a return type, you actually can define that method. So it just looks like, so this really just looks like any other service interface that you would define, that you'd call from your, say, REST client controller. But it actually interfaces into the whole Axon world and does all that asynchronous behaviour for you behind the scenes if you want it to. So here we're saying, let's throw, this method can throw the not started exception if you haven't started whatever the user registration process is, for example. And because it's strongly typed, you know that you're going to get back a status object. So that's how you get commands into the system. You just create that interface that defines your commands, you define your POJOs for your commands, and then all that infrastructure is handled for you. Now, how do we actually handle commands? At the lowest level, you create a command handler and subscribe it to the command bus. But Axon is all Spring aware, so and annotation aware. So they actually make things a bit easier for you. So for example, let's have a user command handler class. It's just a component, so it gets instantiated by Spring for you. It auto wires in the Axon repository, and then you just define methods with the annotation command handler, which then take the type of the command that you're interested in. One thing I was still playing around with, I'm just not quite sure how it then works with immutables too well, because you have to use the class type. So here we're having to use immutable start command rather than start command, which is the interface. It's not much of an overhead, and you can set up immutables to create your classes, with different naming conventions. So it just felt a bit untidy when I was doing it. But yeah, so you create your class. You can imagine it just like a service implementation, with just annotated with command handlers to do it. So the sort of canonical life cycle that you'd use is whatever goes and creates your domain object, you would, in a command handler for that command, you'd talk to the repository and say, please add this domain object. We'll talk about domain objects in a few minutes. Yeah, so here we just create our user object, happen to be passing in the command to the user object to construct it, but that's, you'll see later how that works. And we just add it to the repository. Other types of command handlers, the pattern would be you'd ask the repository to load the specific instance based on its ID, which you'll get from the command, and then you just call a business method on that object. So user get status, and if you return a value from your command handler, it will then get passed back through all that framework, and all the asynchronous wiring that will happen for you, etc. So let's actually look at the domain object itself. So there's a concept in here called where they call the domain objects aggregates. The idea being that you're actually logically working with a group of entities potentially that is always kept in a consistent state. So you might have customer and address, where customer is the first class object and addresses is a subsidiary one. You don't work with addresses independently, and addresses and customer are always kept in state, in a consistent state. For example, if you've got entities which need to be handled differently, different life cycles, for example, not life cycles, different update structures, I guess, they would be two different domain objects, two different aggregates. But the important point here is you've always got a single root entity. You may only have one entity, but you've always got at least one. Brilliant. Yeah, so your aggregate represents your domain object. So the important point is you actually build your business logic into your domain object. So perhaps unlike Hibernate, where we might not typically put the business logic in the Hibernate entity, we might put that in, say, a service layer. With this pattern, you actually do put it in your business logic, and it guards its own invariants, and the idea being that when its state changes, it issues a domain event, which represents what has happened, and then that gets stored as the event stream. So specifically in Axon, every aggregate has to have a unique identifier, which the actual class that you use for your identifier has to implement equals hashcode to string. They have to be consistent, and preferably it's serializable. It all depends on how you're actually storing your aggregates, but that's their recommendation. Then to actually implement it, you have to implement or extend the aggregate root interface, I think it is. There's a couple of interfaces. So there's an event-sourced aggregate route for any aggregate that is actually going to be event-sourced. You don't have to use event sourcing. And then they've got a concrete class, abstract annotated aggregate route. Bit of a mouthful, but that provides a whole bunch of infrastructure for you for building event-sourced aggregates. So as you'll see in a minute when we actually look at some code, actually your class is pretty much just the sort of business logic and event handling that you would expect. So in your aggregate, what sort of state do you need to store? Well, your aggregate is actually never used for your queries. So actually the only state you need to store in your aggregate itself is any state that you need to handle your business logic. So to determine your invariance, etc. And to say, yes, am I able to handle this command? Yes, no, whatever. So actually you find you don't actually have all the state in there. As we'll see in a minute, with our user aggregate, it doesn't store the password, it doesn't need to, because you never determine whether you can change state based on the password. That's just for querying later on, say, is this user's password correct? So alongside state, you have a collection of methods. They are broken down in an event-sourced aggregate into two different types. One for event applying, and one set for actually handling your commands. So how do they work? Well, the event applying ones are there given a historic event, one that's happened. Please apply that state, whatever state change we need in our aggregate, based on what that event told us happened. So we use that when we're basically loading up the current state of the aggregate from the event store. So it creates an empty one and then applies each event. So it calls your event applying methods for each type of event, which will update your internal state, so you get to the point where you're now at the current version before you then apply a command handling method. So that checks invariance and then applies or fires, publishes the appropriate events for that particular state change. So let's have a look at some code. So we've got a user aggregate here. It extends the base class. It's a type string saying basically the ID for this is a string. It has an aggregate identifier, just to say, well, this field is the identifier, which helps it persist and what have you. And then it has to have an empty constructor. So that's so that when it loads it from the beginning, creates a blank instance and then applies these events. So earlier I showed you the command handler class, and that had that pattern of for creation methods you create an instance of your aggregate and then call repository add. That's pretty much all you ever do in a creation method. And in your other methods you always do repository load based on an ID and apply and call a method on your aggregate. You don't typically have much processing inside your command handler class. So what Axon actually allows you to do is they say, well, see, if that's the pattern you've got, if you haven't got any logic there, we can throw that class away for you and we'll use annotations on your aggregate itself to just do that. So if you have a constructor on your aggregate which takes a command and is marked as a command handler, it will say, oh, okay, well, that obviously means that you want to construct an instance of this based on this command and add it to the repository. So it'll do that for you. And so all this method is doing is it's saying, right, I'm going to take my command and then I don't need to do any validation at this point, I'm happy, but I'll just always create my instance. And it calls apply with an event. But it's creating it saying, right, I've been asked to create this user, I'm happy, I'm going to do a user created event, please apply this, and the apply method based off the base class will do all the work to get it into your event store, etc., publish it onto the event bus, so you don't have to worry about it, you just call apply. and note that it doesn't actually do any state change here. It could do if it wanted, but there's no point, because we know from what I said earlier that as soon as it's finished this operation for this command, it's going to throw that instance away. So you don't need to update the state here. As we'll see in a moment, the event handler methods are ones that will do that. So another couple of command handlers. So these are ones which these aren't construction ones, these are the ones which do the repository load and then apply the command. So they determine, well, what state change events do I need to publish based on what's changed. Then we get on to the event handling side. To do this, you just implement another method for each of the events you're interested in and annotate them with event sourcing handler. And this says, right, okay, so when I'm constructing my object, I'll create a blank one, I'll read each event out of the data store, out of the repository, and then I'll find the particular method on the aggregate that I apply that event on. So these do then update the state on the aggregate. So the first one's just setting the ID, because it's part of the create, and then there's a onDeleted method, and it's calling this special method mark deleted from the base class, which essentially tells Axon, right, we're at the end of the life cycle for this aggregate, it's being deleted, don't allow any other commands to be issued to this object, it's finished. Obviously the events still stay in the event store, they don't get deleted at that point because they are facts of what's happened in the past. But also note, we don't actually have an event handler here for the password change event. We don't need to implement it because we don't have any, doesn't actually affect the state internally in the aggregate. So, how do we actually store those? How does Axon?
Why doesn't it change the state in the aggregate? Why change the password?
Because the aggregate doesn't need to know what the password is in order to do future state changes or future event handling. And it's never queried, so you don't say, please tell me what the password is so I can check that the user's okay, I've got the right password. You do that in the querying side of things. So they'll get the password change event in the query side of things, they'll store that away in some database that they will then query later on. But your aggregate, you never actually ask it again, what's the password, in this particular aggregate's case. So you only need the things, and it's quite
weird.
It was quite a eye-opening moment when I realised this, and I think Chris May said the same. That actually you only need to keep the state that you're interested in, that helps you determine whether you can apply future commands, how it affects the life cycle of that object.
Yeah, it's passwords are read things.
Yeah.
Basically, the aggregate is a view of your data.
Yeah.
It's just a different view.
So you'd only want it on there if, say, there was something that said you can't have a password the same as the previous password, you can't change it.
Yes,
So then
you might do that.
To read
yeah. But the other thing that you can do is your aggregate can actually check outside things. So it could query, for example, to check other things as well, to help it determine that state change. So probably in this case, if it was about its own password history, it might keep it internally because logically it's its own state. But you might have something that says, well, I can't have two users with the same user ID, for example, or username. Then you'd have to do some other mechanism. And there's a few ways you do that. You could either do it in, say, a command handler layer before you issue a command at all into the aggregate, or you could build it into the aggregate. So one of the things I'll talk about in a moment is actually how you do that injection, but only very briefly. So, the repository is provided for you by Axon again. You don't have to write that. You can do, it just standard interface. But because it's very simple, you're never doing querying. All you're actually ever doing is appending events and reading them back out. It's pretty simple. So it only has to implement add and load. They provide a couple of different types. A standard one, which is just for storing the current state only. But I think the most interesting side is actually the event sourcing one. So they provide an event sourcing repository which stores those events for you. And in that case, they've just got a standard schema that they use. They just store a blob, which is the serialized version of the event, and then some header fields which tells it which aggregate it was, when it was, who did it, etc. So you don't have to manage the schema for those models. You just say, right, okay, that's a standard schema for them, go away, I don't need to worry about migration, etc. We'll talk at the end about migrating the data, but it's pretty straightforward. And then how do you actually use it? So the event sourcing repository is made up of two different components. An aggregate factory and the event store itself. So the event store is just literally the place it puts the events, it just appends them, and then it needs to be able to read them in order. The aggregate factory is the thing that handles things like dependencies. So in its very simplest form, all it does is it creates an empty instance using that no argument constructor of the aggregate. But if you imagine that you might want other dependencies, like say a query, you might need to query something else, you'll need that dependency injected. So the aggregate factory is there to handle those objects. Because unlike just standard Spring components, which are singletons that get created at say start time or based on a particular Spring scope, your aggregates are being constructed and thrown away all the time. And the aggregate factory is there to, when it constructs it, say, what dependencies do you need? Oh, I'll need to inject them for you. But I found I didn't need to do any of that because I did that all in my command handler. But you can do that. The other thing the aggregate factory does is caching. So, as I said before, when you ask for an aggregate, it says create a blank one, apply all the events, and then apply the command to it. Obviously, if you've got 10,000 events, that can take some time. And you know, if it's the case that you're applying lots of commands to it, and each time you only produce one event, you might as well keep the one you had in memory and just apply the one event that you've just created to it and say, well, next time someone calls a command, just give them that instance, rather than applying 10,000 of them. And then there's a specific case of that caching called snapshotting. So caching will only work in memory on the single instance that you've got. You know, so if you've only got one server, yeah, that might work. If you've got 10 servers, that's perhaps less of an issue if you're sending your commands to different instances. So they have snapshotting. So what they'll do is they'll say, every 50 events, say, we'll take a snapshot of the state of the aggregate, and next time you ask for it, I'll give you that snapshot and then apply any events on top of it that have happened since that snapshot. That all happens for you under the covers. You don't need to worry about it other than to configure it in your Spring config, which then will happen across any servers you've got, etc. And you can throw away those snapshots, of course, because you can always rebuild them from the original event store, as long as you've got all the original events. So that's the sort of command side of things, and I'll move quickly on to the query side and how we actually use that. The querying side actually is very straightforward in the sense of you just want to query anything any way you want. You might send messages, etc. So CQRS, so Axon doesn't actually provide you much infrastructure for this because you can just do it however you normally would do it. The only things it does provide really is the mechanism for getting events, because obviously you have to tie into their event scheme. So they have event handling, they have an event bus which you publish events to, and then they get sent to every listener you're interested in that event. So unlike command handling, which has a single command handler, you want event listeners, multiple event listeners per event. They've got a bunch of different implementations of your event bus for you. The simple one, again, happens in thread. So if you use a simple command bus and the simple event bus, actually everything from the command dispatch through to writing to the database and your event handlers all happens on the same thread, probably in the same database transaction, making your application actually really simple. You don't have to worry about any of this asynchronous behaviour at all at this point. So you could build your application from scratch, starting with that approach, and it's very similar in that case to just a standard CRUD application or a Hibernate application. Very simple from that point of view. And later on you can make it more complex by saying, well, I'll introduce asynchrony here, or something like that. If you do go beyond that, they've got a clustered event bus which does it over multiple servers, so it'll dispatch events to multiple servers, and they can do it asynchronously and in parallel. So you can say, oh, have 50 threads all processing events as they come in, please. We don't care. We'll talk a little bit about that in a moment. So how do you actually do this? All you do is you create an object, probably a Spring component again, and annotate it as event handler, and take the event type that you're interested in. And that's it really. Then you can just do whatever you want. So here I'm just using JPA to create a copy of my user entity and store it in a specific JPA database for my users. It's not my master source, it's just a view of my entities. And it's only got the current version in it, so there could be another one here for handle the password changed event, which would update the password, and then it could be, for example, the Spring security data source for just using Spring security. In my sample application I did, that's what I had built. So parallel processing. So this is where you want to actually get that extra throughput, run the event handling in parallel. All you need to do is provide it a thread executor, and it will go and do that on multiple threads for you. The thing you have to be aware of is what the sequencing policy is. So sometimes you're just happy that events happen in any order, you don't really care, but probably you do. So you've got some standard sequencing policies, such as all events for a single aggregate instance or aggregate ID are handled sequentially, but between different aggregates they can handle in parallel, which is probably the one you'd want. But they've got standard stuff for that. If you're doing parallel processing or asynchronous processing, you do need to be aware of eventual consistency. If your command handler returns immediately because it's dispatched the command, your client might then do a query and expect to see the result of that already done, but that event might still be flowing through the system. So you have to be aware that you might see things that are older than the last command that you've issued. Most of the time that's probably alright if you're happy with that, but you just have to be aware that you have that constraint if you switch on the asynchronous and parallel nature of Axon. But if you don't, if you're just using the simple processes, it's absolutely the same as any other straightforward say CRUD application that we build today. Right, so the final area I want to talk about is managing complex business transactions. So they have this concept of a saga. So an example that they talk about is money transfer from Bank A to Bank B. Now, Bank A and Bank B, you can imagine, don't actually have a single data centre with a single database. They've got multiple. One would hope their databases are separate, probably in different data centres. So you can't actually coordinate a database transaction between them. So the canonical example everyone talks about, we're talking about ACID transactions, is transferring money from account A to account B. Well, that's not how banks really do it. There's often a paper process in the middle with a cheque. So it can take days to complete. But Axon provides support for actually handling those types of transactions. So the idea being that, well, you can't roll back a transaction, you have to always make an eventual consistency, and if you want to cancel a transaction, you have to do a compensating event to get rid of it. So if you do a debit, Any minute you go, oh, I didn't want to do that, you have to send a credit, for example. So how do we do this? Well, the Saga instance represents an individual transaction. So you might have multiple Saga instances for the same domain object, if there are multiple transactions happening, business transactions happening for that domain object, or you might have none. There might not be any in progress at any particular time. Because it's all event-based, Sagas are kicked off by an event and they're finished in response to an event as well. So you actually just implement your Saga as a set of methods on a class which have annotated event handlers, which we'll see in a moment. One thing to be aware of, because a Saga can apply to multiple domain objects at any one time, you have to be able to say, well, which instance of the Saga is tied to which set of the aggregates. So, as we'll see in a moment, I've got a Saga which is to do with users and profile objects. So you need to tell it that user 5 is associated with, on this business transaction, with profile 72, for example. So it needs to know how to do things. So how does it start off? You just create a method, mark it with start Saga. That will tell it, right, when I process this, create a new instance of the Saga and give it an identity, and we'll associate it with the user ID property of the event. Or we'll have a concept of user ID and we'll pull that out of the event. So it's saying this is an event handler, user ID is the property we're interested in. This Saga says, if we create a user, let's go and try and create a profile for it. So it creates a new ID for a profile. So typically in Axon applications, you'll find that the ID is not auto-generated for you in the database, like you would do with, say, a CRUD app, but you generate it yourself. So there's quite a lot of stuff about, well, typically they seem to use GUIDs, but you don't have to do that. You could use a sequence from the database, but it's usually external to Axon that you go and do that. You generate it up front and then say, put it on my command, and then that will now will represent the ID of the object we're interested in. So that's what we're doing here. Creating a profile ID, and we're saying, right, this Saga's instance, this business transaction, will also be associated with profile ID 57, whatever in this case. And then we send the command to the profile gateway to say, go and create my profile for me. And then this business transaction will run until we find out whether we successfully created the profile or we didn't. So, how do we do that? Well, you can have any number of intermediate steps which are just marked with Saga Event Handler, but at some point you want your transaction to be logically completed, and you do that with an end Saga annotation on an event handler method. So, in this case, again, we're saying when we receive an event whose profile ID is the same as the one that this transaction's about, call this instance, end the business transaction. So this is saying if you've completed the profile, right, that's it, we're all fine, that transaction is finished, we know that we've got a consistent user and a consistent profile. But if we've got a rejection, a profile rejection event, we want to say, okay, so our business transaction didn't actually work, let's do something to compensate for that, so we'll send a disable user command. So you can build quite complex transactions and flows for your event handling. So, what happens if you want something to happen when nothing has happened? So this is all based on we get an event saying profile was created or profile was rejected. Well, what happens if you want to say, if they haven't paid my invoice within 30 days, I want to do something? How would you do that? They support scheduling. So they can set up an event to say, send me an event in 30 days to tell me to check the invoice has been processed. and pretty straightforward. You create the event you want to get sent at some point. You call the scheduler to say, please schedule this event at some point in the future. And that can either be a duration, so in 30 minutes time, or at a particular time, etc. And your schedules can be persisted using something like Quartz, or it could be in memory, depending on how you want to do it, whether you want those events to go over a restart of the server. They also will give you a token back from your scheduling, so that you can cancel the event publishing if you want. So if we do receive the invoice and we've processed the transaction, the event saying invoice paid, we can say, right, we don't need that event to be published to us again in the future. Okay, so what do we need to think about? That's it from the point of view of what I'm talking about. There are a couple of things. If we do interact with external systems, then we need to think about how we handle the replay of events. So you saw earlier the diagram, one of the options was let's send an email. If you want to rebuild your system, because you say, right, I'm going to throw away that, that data set from that query engine because it's either got out of date or because I want to do something completely different, you can reconstruct it by replaying the event. But you probably don't want to send out emails again, I assume. Axon does provide some mechanism to say, oh, I'm in replay mode or not, but it's something you just need to think about when you're designing the system. And if you think about, well, how am I going to handle replaying events? Similarly, if you're talking to external systems, they are probably not event sourced. So you have to think about, well, how would I interact with them on a replay? Or if you're building a system where when you get an event for your query engine, you query someone else's system, that system might be in a different state every time you get that event if you're replaying it. So how do you manage that? So it's something to be aware of, something I haven't really looked into in great depth, but it's a known thing that you have to worry about and think about what you would do. And then, so the final area is code changes. We talked about data migrations earlier, so we were talking earlier today about using Liquibase and how we migrate the data in our database as we add new functionality and change the code. Axon's got its historic store of events. You could, in theory, go in and apply a migration to that set of historic events, but potentially you could screw it up. That was also a fact about what happened at that point in the schema of the event at that point, so that's probably quite useful information. So Axon provides the ability to handle what they call upcasting of historic events. So you get, while it's replaying that event, you get to transform it into the latest schema format. So if I'd only been 1 minute quicker, we could have got straight to questions at that point. Yeah, so that's it. Any questions? You can find out more at axonframework.org. So my view is, it seems a pretty reasonable framework. I don't think it adds a huge amount of overhead over and above what we would traditionally do with, say, a REST front end, then a service layer, and then some sort of data repository. I think actually, it's probably comparable. I'd like to try it on a sort of mainstream project and see how it actually works. But one of the big advantages I think we'll get is that separation of concerns, hexagon architecture ideas, the ability to hive off microservices more easily if and when we wanted to. So, yeah, thumbs up from me. Any questions?
How is the event store persisted? Is there a storage backend for that?
Yeah, so there's one thing I forgot to mention is they provide a number of different implementations of the event store. So there's a file-based one, if you want to just store in a file. There's a JDBC one, where they just have define a JDBC schema and they use Spring's JDBC template to store it. There's a JPA one, where they will provide, they've got some domain event entities and domain snapshot entities, which will store the data for you. There's a MongoDB event store, and then you can implement your own if you want. So, yeah, they've done quite a lot of work to be flexible, and because they're all very nicely, neatly separated components, you can just plug in a different component at any of these points. So, a different command bus, or a different event store, or different aggregate factory, or whatever.
The password one was interesting because if you are creating a user with the password,
Yeah.
Currently our systems, the password goes across in plain text, you check it, munge it, save it in the database, and then the database has only got the
Yeah.
hashed version.
So my implementation of this, so just a little bit of an advert, I've written a sample app for playing with this stuff, which you can find at that address. It's based on Spring Boot, with Axon obviously, Angular front end using TypeScript, because I'm playing around with TypeScript, and Angular material design. You can find it there. There's a screenshot. Not very interesting, but that does do user management. And what I did was I did the encryption of the password at the REST layer. So all my commands had encrypted password in it, because I was thinking, yeah, the password would be end up being stored in plain text in an event object in my event store. So yes, you do have to think about that. You can't just, you could just store it in plain text and hope or plan for your event store to be protected, but you know, you've got the same issues there as you might as well store it in plain text in an encrypted database anyway. So yeah, so I hashed it before I put it into my command. I guess you could put it in your command and then hash it before it goes into the event, because the commands always get thrown away. Events are the only thing that gets stored.
How do you decide where to put your business logic, whether to put it in the commands or within the domain objects?
So don't put it in the commands. Commands are just basic plain data carriers for the data. The only things I had in my command was annotations for validation processing.
So the command doesn't
So the command is just a data carrier. I mean, I guess you probably could, but the idea is you would put it in your aggregate itself, or at worst, the command handler in front of it. So I did a little bit of business logic in my command handler, because I wanted to make my create events idempotent. So you could send multiple commands idempotent. So you could send multiple commands in, and it would say, oh, I've already created that, I won't bother running that. But I think their intention is you actually do it in your aggregate object itself. You know, it's the place that is the controller of the business logic for it. If you've got coordinating business logic, then you'd put it in a command handler probably.
And that's outside of the domain object.
Yeah. But as I say, as you saw, you don't need a command handler layer at all. You can just build that into the aggregate, and you can inject things into your aggregate using the aggregate factory. So if you do need to query external things to make decisions inside your aggregate, that's the way you would do it. I haven't actually had to do any of that injection stuff.
It's a bit different to the command pattern.
Yes, yeah, it's not the command pattern in that sense.
Yeah.
Okay, any other questions? No? Feel free to check it out. I can't comment on the quality of the code because it was just me and had no pair, but I'd be interested in any feedback that you've got.
Thank you very much.
Thank you.